Today we're going to talk about combined transformations. So when we aren't told in advance, you are going to be shifting a function or you are going to be reflecting a function. How do we know what type of transformation is occurring? These were the 8 transformations that we've talked about, and I've grouped them into things that are happening outside the function and things that are happening inside the function. And pretty much in every case, whenever anything is happening outside the function, it's happening to the y-coordinates. And when something's happening inside the function, it's happening to the x-coordinates. And you should be able to think of that in terms of here, what's inside is the input, that's the x-coordinates. Whatever's happening outside, that will be more closely related to the output, the y-coordinates. So we said that this was a shift up, and this was a shift down. When we subtracted inside, that was a shift right. And when we added inside, that was a shift left. And that matches with our x-coordinate, y-coordinate theory. When we multiplied by 2 outside, what happened was we went from the x-axis and then we stretched vertically. Whereas if we multiplied inside, that compressed toward the y-axis. Compressed toward the y-axis. Whenever we have a negative, it will be a reflection. And when we're changing y-coordinates, then that means that it will be a vertical reflection. And when we're changing x-coordinates, when we're doing it inside, it will be a horizontal reflection. So these are our key things. One thing to note is I didn't list out how we would compress toward the x-axis or how we would stretch away from the y-axis. That would be the exact same thing as these, except instead of multiplying by 2, we'd multiply by something like 1/2. So multiplying by 1/2 outside compresses toward the x-axis. Multiplying by 1/2 inside would stretch away from the y-axis. Back in geometry, we talked about rigid transformations. And a rigid transformation is one that preserves congruence. The 3 that we're looking at are translation, rotation, and reflection. So of these, most of them are, in fact, rigid transformations or rigid motions. Whenever we have a shift, those are translations, so those all count. Whenever we have a reflection, those all count, but not the ones that are stretches. We also don't have any rotations listed here. But if once we multiply by something other than 1 or -1, it no longer is a rigid motion. So a few practice problems. Write g of x in terms of f of x. So g of x in terms of f of x. So we're going to have f of something. We might have things happening outside the function. What you should do in order to write g of x in terms of f of x is figure out how g of x is being changed to turn into f of x. So there's clearly a reflection going on here. These two things are switching places across the x-axis. And whenever two things are exchanging places across the x-axis, that's changing the y-coordinates. Changing the y-coordinates would be outside the function. And reflections are negatives, so that's why I'm going to write negative f of something. If we just had a reflection, this point would stay in place, 2, 0. is on our original f of x, it would stay in place as 2 comma 0. But I think it's clear that this is moving to the left. This point on f of x not only got translated left and reflected across, this point got translated left and reflected across. So that means that we're shifting left. How far are we shifting left? We're going from 2 comma 0 over to this point, which we know is 0 comma 0. So the shift is left by 2 units. And how do we shift left 2 units? We add inside. So that is how we write g of x in terms of f of x. Write f of x equals 2 natural log of x plus 4 minus 20 as a transformation of the parent function. What transformations are there? So first of all, we should identify what the parent function is. It's very clearly natural log. That's the most interesting thing. So g of x equals the natural log. How would we write this function as a transformation of that? Well, just wherever there was natural log, we're going to instead write g of x. So we have x plus 4 inside and then minus 20 outside. That's supposed to be a 4. Okay, so what are the transformations? There are clearly 3 transformations going on. We have the 2, we have the 4, and we have the negative 20. The first thing that's happening is that the adding 4 is happening. I like to think about this as what's happening to the x first. So the 4 is happening. That's a shift left by 4 units. Then the next thing that will happen is it will go into the natural log. And then after that, we are multiplying by 2. Outside, that would be a vertical stretch. So a vertical expansion away from the x-axis by a factor of 2. Lastly, we're going to deal with the negative 20. So we shift which way? Outside would be up, down, and negative means down. Shifts down by 20 units. So those are the transformations to get from our parent function of natural log of x to f of x. Thanks.